Welcome back to part 2 of our Unity tutorial, to create a Flappy Bird clone for absolute beginners. In the last part we learned something about Unity and game development in general. We covered also the installation and interface of Unity. So if you did not already check that, feel free to check my channel or the description of the video to find it. Otherwise let's start with part 2. So let's add some physics and basic controls. With our bird on the screen, it's time to give it some life. We want our bird to fall using gravity and flap upwards when you press a button, just like in the real Flappy Bird. First, let's add a RigidBody 2D component to our bird. The RigidBody 2D will make our bird obey the laws of physics, specifically gravity. With the bird selected in the hierarchy, go back to the inspector, click Add Component, and search for RigidBody 2D. Once added, you'll notice several settings pop up, like mass and gravity scale. For now, we'll leave these at their default values. When you press play, you'll see the bird fall straight down off the screen. That's gravity at work. But we don't want our bird to just fall, we want it to be able to flap its wings too. To prevent it from falling through everything, we use a collider. Just add a circle collider 2D to our bird to give it a physical boundary. This collider will interact with other objects in the game, like pipes or the ground. In the inspector, click Add Component again, and search for Circle Collider 2D. You'll see a green circle appear around your bird in the scene view. This is the boundary that will detect collisions. We can adjust it using the offset. Make it a little smaller than the bird for a better game feeling. Now for the fun part, let's make our bird flap. We're going to write a script that tells the bird to jump upward whenever we press the spacebar. Right-click in the project panel, go to Create, and select C# script. Name this script Bird Controller. After that you can add it to the game object. Just double-click on the bird controller script to open it in Visual Studio. Now Visual Studio is open and provides all functions for us. One is IntelliSense. IntelliSense in Visual Studio is a feature that helps you write code faster by suggesting code completions, showing tooltips with information about functions or variables, and detecting errors as you type. It's like an autocomplete for coding. You'll see some default code already written, but we're going to add our own. We're working in C#, which is the programming language we're using. The main focus for now is on these two sections, Start and Update. Start is used for code that executes as soon as the script is activated, and it runs exactly one time. On the other hand, Update keeps running continuously while the script remains active, executing its code every single frame. Let's walk through the process of setting up communication between our script and a RigidBody 2D component. Initially, when we create a script, it can only interact with the game object's basic parts, like the transform. But right now, this script doesn't know anything about the other components attached to the game object, such as a RigidBody 2D. To fix that, we need to create a special reference for the RigidBody 2D, which allows us to interact with it and send commands. We'll start by creating the reference. We'll declare a RigidBody 2D slot in the script. This creates a space in the script to store a RigidBody 2D, and the name myRigidBody will act as our way to refer to it. Because we made it public, this reference will be accessible from outside the script. Now, after saving the script and going back to Unity, you'll notice that the script now has a field for RigidBody 2D. We can simply drag the RigidBody 2D component from the game object into that slot, and that's all. We've established a connection between the script and the RigidBody 2D. Next, let's move back into Visual Studio. In the Update function, we'll start by typing myRigidBody. Once you type the dot, you'll see a list of properties related to the RigidBody 2D component, such as angular drag, gravity scale, and mass. For our script, we're interested in the velocity property. We want to set the bird's velocity so it moves upwards. We'll do this by assigning a new value. myRigidBody velocity equals vector2.up10. Here, we're assigning a vector2 value to control the bird's movement in 2D space. Vector2.up is shorthand for 0, 1, which points straight up. By multiplying it by 10, we're giving the bird some power, sending it upwards with more force. Remember, since this code is inside the update function, it will execute every single frame while the script is active. Let's change the value with another variable. We write public float flap strength equals 5F. Because it's also public, we can change it in Unity and play around with different values for the bird force. Cool or? But if we save now the script and start the game, the bird goes up and up and up. It's because the update function, it will execute every single frame. So we need a if statement where the line is only active if the condition are fulfilled. What is a if statement in C# or in general? An if statement in C# and most programming languages is used to make decisions in code. It checks whether a condition is true or false. If the condition is true, the block of code inside the if statement runs. If it's false, that code is skipped. We'll use Unity's input system, specifically the getKeyDown method, which checks if a key was pressed during the current frame. Start by calling input and then use getKeyDown to detect if the spacebar was pressed. This asks Unity to check if the spacebar was pressed on the current frame. Since we only want this to trigger when the spacebar is pressed, we'll use if to wrap it and only run code when it's true. So the if statement checks if the spacebar was pressed, and if it was, the code inside the curly brackets, which we can think of as a fenced area, will be executed. This is where the bird flap code will go. Now, every frame, Unity checks the condition: has the spacebar just been pressed? If the answer is yes, the bird will flap. Now, hit play and press the spacebar, your bird should flap and rise up. You can adjust the flap strength in the inspector to make the game easier or harder. That was another step in the world of a game developer. Looks very good for this small part of code in the script, or? Let's do a little summarize of the stuff in this part. We can use code to dynamically change the properties of a component while the game is running, pretty powerful stuff. But, here's the thing, by default, a script can't talk to other components on the game object directly. We need to establish a line of communication by storing a reference to the specific component we want to control. We create that reference in the script, and then in Unity, it's as simple as dragging and dropping the component to fill it in. Now, remember how code works. Start runs once when the script first comes to life. Update runs continuously, firing off code every single frame. But here's the magic: we can use if statements to run certain code only when a specific condition is met, like pressing a key. And, by making variables public, we unlock the ability to tweak those values right in Unity's inspector, even while the game is running. Alright, that's the foundation for building Flappy Bird. It may look simple, but with these mechanics, you've got everything you need to make it soar. Now that our bird can flap and fall, let's add some pipes to dodge. The challenge of Flappy Bird comes from navigating these pipes, so it's crucial to get this right. Let's start by making a new game object called pipe. We'll position it right on top of the bird for now to get the size right. Next, within this pipe game object, create another one called top pipe as a child object. This allows us to nest multiple objects, so we can move, scale, or rotate them all at once by controlling the parent. Now, add a sprite renderer for the pipe image to the top pipe. Once the top pipe is ready, move it above the bird, keeping the X position at 0. And add a box collider 2D so the pipes can interact with the bird. We don't need a rigid body here because the pipes won't be affected by physics. Now, duplicate this top pipe object and call it bottom pipe. Flip it upside down by changing its Y scale to -1, and move it below the bird. You'll see that when we manipulate the parent pipe game object, both pipes move together, with the parent acting as the pivot. Now, we need to move the pipes across the screen. Add a script to the parent pipe object to control this movement. We'll start by creating a variable called moveSpeed for how fast the pipes move. In the update function, we'll change the pipe's position using vector 3 instead of vector 2 since Unity tracks objects in 3D space, even in 2D games. To move the pipe to the left, we'll write some code. Delta time ensures that the movement is consistent across different frame rates, so the pipes won't move faster on more powerful computers. Next, we'll create a prefab so we can spawn multiple pipes. Drag the pipe game object from the hierarchy into your project window. This creates a blueprint of the object that we can reuse as many times as we want. You can delete the original pipe in the hierarchy now, since we'll be spawning it dynamically. Now, Create a new game object called pipe spawner and position it just to the right of the camera. We'll add a script to this spawner to spawn new pipes at regular intervals. In the script, we'll reference the pipe prefab like this. Public game object pipe. Create two variables, spawn rate for how long we want to wait between spawns and timer to count up. In update, we'll increase the timer by time. For the pipe spawner, we create our own method and start it in the start method. Next, we'll write the code to spawn pipes. Unity has a built-in function called instantiate that lets us create new game objects. We'll use this to spawn the pipes at the spawner's position. To prevent pipes from spawning every frame, we'll implement a timer. Delta time and check if it has reached the spawn rate. If it has, we spawn a new pipe and reset the timer. Let's make a quick check if it's working. Yes, looks fine. The pipes are spawning and we can adjust the rate by our variable direct in Unity, but you see in the hierarchy panel that there are more and more pipes. This is because no object will destroy it after it leaves the view of the player. So we need to remove pipes once they move off screen. Otherwise, they'll just keep running in the background and waste memory. Add a check in the pipe script to see if the pipe is out of view. If it is, destroy the pipe. For this we create the variable dead zone and check in the update from our pipe script if the transform X position is greater or not. If yes, we destroy it. Now it look much better. You can see this also much better in the scene view. Just zoom out and see in real time the spawn of the pipes and also the destroy of it after the pass the point. Let's make the game more interesting by randomizing the heights of the pipes. Create a public variable for height offset, set it to something like 10. Calculate the lowest and highest spawn points by subtracting and adding the offset to the spawner's Y position. When spawning the pipe, we'll use random range lowest point, highest point, for the Y position. Now the pipes will spawn at random heights. We change now our new created spawn position with the transform position the instantiate for our pipes. And now let's check. Yes, look really cool. Pipes are spawning in different high like the original game. But you see also a little issue in the pipes itself. It seems at some places that the pipes are not high enough to fill the complete view of the game screen. Let's fix that in the prefab from the pipes. Just open it and adjust the pipes in high and space to each other. Now it looks nearly perfect. Cool stuff. Let's do a little summarize of the stuff in this part. In this step, we created pipes as nested game objects, set them to move across the screen, and set up a spawner to generate new pipes at random heights. We also learned how we can turn game objects into prefabs. Just dragging them from the hierarchy, and dropping them into the project. That's all. So we can use it on all places that we want. Cool stuff, or? We also made sure that pipes get deleted once they go off screen to prevent memory overload. And with the timer system in place, pipes spawn at a controlled interval for smooth gameplay. That's it for this part. With the pipe spawning and moving, our Flappy Bird clone is starting to take shape. Now you can take your time to check again this video and try on your own to implement if not already done all the stuff. In the next part we created a simple UI to display the score of the player, and we also include the logic manager. This game object tracks the score and updates the UI. We also implement a game over screen with restart function if the bird hits a pipe. So don't miss the next part, and happy coding. I linked you the next part in the description. Feel free to check also my channel for many different topics and tutorials.